All right, welcome back, guys. So I want to do a video, separate video on lesson 5.2, on a word problem that uses antiderivatives and relate to some of the functions we study in this class. And those one of the functions we study in this class is called price demand function. So in this problem here, we're given that the marginal price for weekly demand X bottles of shampoo at drugstore is given by the function below. So this is a marginal price demand equation. So marginal is just another word for derivative in terms of the business function. So the derivative of the price demand equation is negative 9,000 over 3x plus 50 squared. We want to find what is price demand equation. We want to find P of X itself. Okay, we want to find that given these information. We're given that when the demand is 150, so when X is 150, P is $8. Okay, so we're given those initial condition. Okay, and we also asked to find that what is X, what is the weekly demand when P is $7.50. So that's going to be the second part of the problem. Okay, so you also need to find, so this is A. Find X when P is $7.50. So there's a lot going on in this problem here. So the very first thing we want to do is find the price demand equation from the derivative. Okay, so we know that P of X, price demand equation, is equal to the integral of P prime of X times dx. Okay, so and the antiderivative of P prime of X is going to be P to X. So that's what we're doing here. So let's go ahead and put that antiderivative in, P prime of X into the integral dx. Okay, so I'm going to do two things. I'm going to go ahead and take the negative 9,000 out, and I'm going to rewrite 3x plus 50 to the second power as the numerator term, so that would become negative exponent. Okay, so I'm going to go ahead and do negative 9,000 comes out, and then this 3x plus 50 now becomes in the numerator with the negative exponent. Okay. All right, so now we can let u be 3x plus 50. Okay, so du is going to be 3 dx. Okay, so notice that du is 3 dx. We only have dx here. There's no 3 there. So using the techniques we discussed earlier, we can say that's the same thing as 1/3 du equal to dx. Just divide both sides by 3. So dx now get replaced by 1/3 du. So now going back over here, negative 9,000 integral u to negative 2 power, because 3x plus 50 is u. Dx now being replaced by 1/3 du. And then now this constant can be brought out, combined with the other constant. So we're looking at negative 9,000 divided by 1/3, because 1/3 comes out, which is just become, times 1/3, which is going to be divided by 3. Integral of u, negative 2 du. All right, so that's going to give us minus 3,000. And then let's see, the antiderivative of u to negative 2, using the power rule, we're looking at that divided by the new power plus c. And then we're looking at 3,000. Let's go ahead and rewrite what u is. That was 3x plus 50 raised to negative 1 plus c. So now our p to the x function is 3,000 over 3x plus 50 plus c. Okay, and we don't know what this constant c, we have to solve for it. And that's where the information is going to come in. This is what the initial condition is going to allow us to solve for that constant c as fully, this is just the general solution of price demand equation. To find the particular solution for a price demand equation, we have to use the initial condition here. This is our initial condition. Okay, so this is general solutions, because c is arbitrary. So now use initial condition to solve for a particular solution. Okay, so our initial condition will be x is 150, p is 8. So x is 150, p is 8. Solve for the constant c. Okay, so we have 8 equal 3000 over 3 times 150 plus 50 plus c. If you do the math correctly, that should give us 8 over 8 equal 3 times 150 is 450. 450 plus 50 is going to be 500. 500 goes into 3006 times. So our c is going to be 2. So now our solution for p of x itself, okay, so solution for p of x itself is 3000 over 3x plus 50 plus 2. And that should be a price demand equation right there. So that's the price demand equation that we asked to find. Okay, so that's going to be part A there. We find what p of x is. Now part B, we asked to find, okay, find the demand level when the price is $7.50 per bottle of shampoo. Okay, so now that we have the price demand equation, that tell us, oops, I think I make a mistake here. That should be a 2. Let me go ahead and erase this. That should be a 2 because we solved for c already. Okay, plus 2. So now we have the price demand equation. Oh, I don't know what happened there. Okay, so plus 2. So now we have the price demand equation. We can plug in certain demand to find certain price, or plug in certain price, solve for the demand level. Okay, so that's gonna be part B. So part B, we're asking to find x, the demand level when the price is $7.50 per bottle. So let's do it. So that means $7.50 equals 3000 over 3x plus 50 plus 2. We're going to solve for x. Okay, so subtract both sides by 2. That will give us, so minus 2, so that gives us 550 equals 3000 over 3x plus 50. So now we can solve for x by multiply by 3x plus 50 both sides. Okay, so that cancel. So we're looking at 3000 equals 3x plus 50 times 550. And I just swap those two sides there. All right, so we can go ahead. So we can actually distribute the 3x, the $5.50 times 3x plus 50. But let's take the 3000 and divide by 5.5. Let's do that. Okay. So let's divide this here. 5.5. So we're looking at 545.45. 3x plus 50. And then now we can subtract it by 50. So we're looking at 495.45 equal 3x. Now divide both sides by 3. So we're looking at 165.15. So the demand is going to be in terms of number of bottles per number of shampoo bottles. So what we want to do is we want to round this to the nearest bottle. So 165 bottles of shampoo. Okay. So what we have so far in this problem is that first we're given the marginal function of the price demand equation. From the derivative function, we can work backwards to find the price demand equation, but that just only the general solution, because when we find the antiderivative, it's a family of antiderivatives. That's what we use C here. So once we use the initial condition here to plug in the equation, we can solve for C. We found C, so now our complete solution is this. And then part B is asking for, okay, well, if we have the price demand equation and all that, tell us, the relationship between X and P. What happened when P is $7.50? Can we find X? The answer is yes. We plug in 750 for X. The algebra a little bit messy, but it's not anything complicated. We plug in this for X and for P, and we solve for X. So we just kind of trace through the step here and then solve for X. And then X is number of bottles of shampoo. So we want to round that to the nearest whole number. All right.